So we'll get going with looking into rendering and also some simulation tweaks and stuff like that. So yeah, was doing a few flipbooks with just adjusting the lighting. Doesn't make a big difference on the, it's just like subtle kind of rim, or I don't know, just one point light way off to the side. But I really like the masking features that they let you do. So I think I could just get the file. I did start to do a little bit of a render just using Mantra from last week's file. So that's right here. But yeah, the masking and the scattering kind of stuff. So if we look at that pyro bake node, it's really cool. Pyro bake volume. What it will do with this scattering is really useful. And then if we take a look at this one, they have the masking. So the masking is taking some of the density and kind of like multiplying it against the intensity to bring back some of this contrast and darkness. So instead of all this stuff washing out, at the start it's kind of nice to bloom it out like an explosion. Super hot values, but then over time it's cool to get kind of just little details and stuff like that. So that's through the masking that kind of happens. All right. So I'm just gonna start back with this scene, but I'm gonna do some tweaks to the existing source shape a little bit. So I think overall it was just a little too uniform, like blobby, spherical. So I want to try to get like a little bit more of the spikiness, so that initially it just has some more like breakup in the silhouette, I guess is the best way to describe it. How's everyone doing? Everyone's watching the Houdini Hive. They're doing presentations today. If you go to, where is it? It's definitely on YouTube, but I think the schedule is right here. I think they're doing some stuff right now talking about Shotgun. Shotgun is like a production artist workload kind of management, scheduling, I don't know, like a management utility. But I need to go back and look at some of the other stuff. So I didn't have a chance to watch this one yet. This one's probably goes super well with what I'm talking about right now. And then the kin effects stuff, of course, is amazing. All right. So take a look right here with these bursts and trail paths. This is also a new pyro burst source and pyro trail path. These are new nodes with 18.5 as well. So they're really cool. Before, everyone had their own way of like setting up particle simulations doing this, but it's pretty nice to have this all in like a simple kind of wrapped up in a nice tool. So right now this creates a bunch of points with the attributes, and then the rasterize rasterizes convert from polygons or points into volume, basically, is like rasterize. So if you use Photoshop, you see a similar like vector raster. This is where the terminology comes from or whatever. Vector is just meaning points in 3D space, like positions in 3D space. And then this means like grids filled with values, like pixels filled with values, or in this case, voxels filled with values. And then I think at the bottom here with burst components. These are kind of linked up, but you can see they're creating density, temperature, burn, and divergence. So all of those are actually fields. If I middle mouse button here, you can see we also have velocity, that's the point velocity, but you have burn, density, divergence, temperature. These are all volumes or fields that get sourced into the pyro solver and used for the explosion. I was also going to a high resolution here. I'm going to reduce the voxel size so that it's a bit smaller. Or I'm sorry, I'm going to increase the voxel size, which will reduce the overall resolution. Bigger voxels, lower resolution. It's kind of a confusing inverse style relationship or whatever. All right. So right now I'm just viewing the source. It's not the actual simulation or anything like that. And then that's why there's these multiple wireframes right now, is because they correspond to different attributes that have generated different volumes, whether it's the velocity, temperature, divergence, burn, or density. So just going back to see where we are right now, these spikes, they do exist, but they really quickly get expanded into or filled with kind of intensity or just explosion. Like they get ballooned out, expanded outwards. So it kind of ruins that initial like detail that we want to keep. There's a few different ways to go about tweaking this. What I might do is just hold down Alt, drag this burst source over to make a duplicate or a copy of it. And then if you want to, you can merge these together. This is kind of like compositing, combining anything like images, compositing frames. Here we're just compositing sources. So merge them together. And then if I want to get maybe a different seed, some different, just combining or compositing two different sources. So I can kind of sculpt this one out a little bit different. If I want the size maybe of it to be bigger, maybe reduce this variation. This one's going to be like the main driver of my spikes. So I'm going to keep these variations quite low to just have it being more like straight up. I might reduce the divergence. We could, before I do that, let me just finish up what I'm doing, changing the shape of things. So you guys can actually see like the visual result that we'll get. I don't know if there's a way to really get I don't have a ton of experience with this node, but just trying to get less kind of frequency or randomness in that area. Kira, how's it going? It seems like cranking this roundness down, you're getting more variation. Like the more roundness you have, it just becomes completely spherical. So I guess doing this spread angle, like if you go all the way up to 180, you have a lot of spikes or high frequency of spikes. So maybe just keeping this spread angle down. We just have these kind of 3 or 4, 5 distinct spikes. M. Sunar, good afternoon to you. So what I can do here is just circumvent the merge if I just want to kind of solo out or only look at this new source. So eventually I'll be combining them. Yeah, so this is kind of a follow-up or expanding on last Wednesday's stream regarding the, where did it go? Booms, the explosions. This file should be shared, right? Did I not do it? You go to the friendly Discord. You do maybe ! Discord in the chat to get a link to it. Or if you have Jabram's file selector, you can see the file from the share history there as well. But yeah, if you go to the Discord, this is the link to the file from the end of 1 week ago, last Wednesdays. Yeah, and if you're curious, just do !Discord. You have a link to join that. There's also !hip. This is how you can get set up with their shelf tools that we've built to manage and import scenes that get shared or distributed throughout the stream. So this is Discord is more of like the history or the summaries. The end files will get shared there, but then this hip sync you use to kind of stay up to date. All right. So what I'm doing, just bypassing the original source and taking a look here. Keeping an eye on not the schedule, not the Discord, this. So this is where we were leaving off. It's pretty nice with like the bubbliness of it, but it's just, especially at the start, it's like almost too uniform. So I'm just looking at these spikes here. Eventually gonna combine both of these sources. You can also bypass, you disable the merge node, and then you'll just get whatever the first input is, the leftmost wire. So I'm trying to use these sources here to get bigger spikes or initial kind of blast. And then the starting shape and everything is pretty nice, but again, it's just quickly expanding outwards and bubbling up and like blurring. So now it kind of turns into a box. From the first few frames, it was we got the nice like spiky cone shapes, but now we're back to just like blobs or bubbles or whatever you want to, mushrooms. So what I was gonna do earlier over here on burst components, this is where you can control, like on the Pyro solver under sourcing, you can control globally things like divergence, velocity, temperature, the global or this level of like multiply the sources. But if you go to the individual burst source nodes, then you can independently kind of scale these values for each source. Is this early stream? Is it early for you? It might. I think we're a week we're out of sync right now, maybe with the EU clocks because of the daylight savings. So like a whole hour earlier. Yeah, the US doesn't update their clocks for another week or 2 weeks or something like that. was the Halloween, the candy industry lobbied our government to stay. They didn't want us to move the clocks earlier until after Halloween so the children would buy more candy. All right. So the divergence is kind of that expansion, or like the bubbliness of things. That's why I waited right now to change this value, just so you could see the difference of that slider. So I went from having it all the way set to 1 to now I just adjusted it to 0.1. So we're doing 10% of the divergence, or you could translate this or think of it as expansion. And you can see now that this shape gets a lot more of the silhouette. Player 2, thank you for continuing the 4-month streak. Tier 1, let's go. Candy companies, the most, it's true, you could look it up. I mean, everything here is controlled by lobbies and big monies and stuff like that. They'll trick you and say it's for farmers, for crops, because they want you to like conjure up imagery of this straw hat wearing friendly guy, but it's a lot of times the reasons are more nefarious than they lead you to believe. Romulus, how's it going? All right, so you can see now we've preserved the silhouette to be a little bit more spiky, just by reducing the divergence from this source. So I'm compositing the two so I can keep the higher. This is a more like expanding, and then this one we're gonna use to do more spikes. So go back to it here. If we don't want this to do as much density, we could even maybe turn that off. Z8 editing, how's it going? And the reason I'm doing this is because I want just this to be mainly doing velocity, like punching or shooting things upwards, but not kind of contributing to too much like visual expansion and things like that. I think if you want to, maybe reduce the particle scale to 1. Reason to reduce the particle scale, if we go to disks, you can see visually here, like just the bigger your particle scale is, again, that's just gonna make things look more blobby and thick and blurry in general. So you go down to 1, you could even go down, if you bring this value too low, you might get like some stepping or like breakup of the shape. But we'll try it with 1 for right now. And I think velocity could maybe go a bit higher, do 1.5. As you reduce particle scale, you might want to keep increasing velocity to kind of compensate. Basically, to keep the same momentum, if you're injecting velocity in less area, like spherical area, you need to make the amplitude of the velocity higher to keep kind of the same like distance that it will travel. So let's see what these changes give us. I'm gonna go back to just isolating this one source I'm looking at right now. How would I have a volume of smoke expand over time? We have a shot where we have smoke leaking out of a building. We want it to drastically expand and dissipate. as it gets exposed to winds, etc. We have the dissipation, the expansion. So I was talking a little bit here. I don't know which method you're using to source and solve and everything like that. But right here I was talking about how this, you might have just missed it because it was 5 or 10 minutes ago. But this divergence attribute that volume rasterized attributes eventually turns into a field or a volume called divergence. This is the main way to expand. Divergence with the pyro solver generally just means expansion. So if I double it and go up to 2, you can see this is causing a lot more spherical kind of like expansion outwards. If I go up to 5, you can see it's just going to keep making more and more expansion. You could advect particles with the smoke and based on age and have them inject divergence. I generally try to avoid doing too much kind of fanciness like that. If you're, the more kind of shaping and things you're trying to do during the simulation, the just longer it becomes to try to control and shape the end result, and then it becomes more and more dependent on like grid size, forces, and things like that that need a lot of tweaking. So for explosions, I generally, or things like impacts, I'll try to nail the initial shape as much as possible with particles, just because they're so quick to visualize and adjust. If you're talking about doing the expansion, Steve, you could try to set that up with advecting particles and having them for the leaky smoke. Take a look at that maybe at the end of the stream or in a little bit. Another way to simulate expansion is through turbulence. So if you just keep injecting turbulence to the area where the smoke exists or the density field exists, that turbulence will have the result of like expanding or pushing things outwards. But that again depends on things like swirl pulse length and like swirl size to choose like just how quickly that turbulence happens over time. So is this new pyro workflow faster to compute than previous ones like OpenCL particles? So there's a lot of factors and things like that at play. There's different options and stuff like that. One thing that they did add in 18.5 is NanoVDB that will take VDBs and transfer them more quickly to the GPU. NanoVDB is like NVIDIA's open source technology, I believe, or contribution to the VDB toolset. So that just allows you to kind of get closer to what I was doing with the particles, which was just less information or less bandwidth to try to upload information to your GPU. And then in general, it's just a decision of whether you want to go with a sparse solver. I think I might have actually switched this to sparse. Yeah. So if you want to, you can either do it with a sparse solver that will get resized over time, or you can do the OpenCL and minimal OpenCL. Minimal OpenCL is basically enabling, turns off caching. It will enable the NanoVDB and a lot of stuff like that. Yeah, in a solver SOP, you can just scatter some particles inside of the inside of them and shape it that way. You can use temperature as well. It's kind of like a balancing act. If you want, you can just do a gas linear combination that will take a percentage or a portion of your temperature or density or things like that and copy it or add it to the divergence field. And then you just have like a throttled kind of expansion. NanoVDBs, I mean, it's hard to kind of isolate it and look at it inside of here. But if you look at, so NVIDIA article, I don't know how easy it's going to be to find. If you search the right terms, because it was Jeff Late. One of the developers for DOPS, or he's the main developer of DOPS, one of the developers for side effects. We take a look at this. This is the link I'm looking at right now. So this is Jeff Late. His title is senior mathematician, but he's kind of the main developer of DOPS. So he's saying with NanoVDB being added to 18.5, we've moved the static collisions of Vellum solver and sourcing of pyro solver over to the GPU. I can't give you the exact like diagram of step by step, like when that's happening with the software code or the workflow of things. But it's basically the idea is that with Houdini's volumes, just look at something like this guy, for example. So if you do ISO offset, the Houdini, you just look and it says volumes. That means you're making a Houdini volume. And I could switch this maybe to size, reduce that by a factor of 10. It's a little, it might have been too slow. But basically the, all right. So the Houdini volumes will take up like all of the voxels. I don't believe NanoVDB is NVIDIA only tech. I'm not 100% sure, but I believe NanoVDB was added to the OpenVDB, like open source toolkit through or because of NVIDIA, but it's not proprietary to NVIDIA, if that makes sense. You might have to do some more investigation and stuff like that into it, but I believe that's how it happens. Like similar things with VDB have happened with other collaborators. If you look at the documentation, you can read about like this double negative was using the VDB technology to store points. And then that was something that they had proprietary to their studio. But eventually they collaborated with OpenVDB to expand on the coding, the library, the tool set. And then eventually it resulted in us getting like VDB points as a not this one, but if you just look at to maybe convert VDB points, pack points into VDB points. So the VDB points became like a thing internal to Houdini or its own like data type essentially. I think that's what NanoVDB is happening. It was like just generic. I think it could I don't know if it's necessarily OpenCL, but I think it's not proprietary. It's not CUDA, or it's not proprietary to NVIDIA only, if that makes sense. So the Houdini volumes, if we look at the bounding box, should show up. It's not doing the best way of showing it. And then I'll just do a VDB from, let's do polygons. And I'm just gonna move this to fog and match the voxel size. So both of these will be doing 0.01. So you can see this is a lot quicker to create it. And then the number of voxels, voxel size is still 0.01, but this is like 300,000 voxels. And then this one, voxel size is like a floating point rounding thing, but it's essentially 0.01 and much more voxels. These displays and things aren't doing the best job to do it, but if I do maybe like visualize tree, basically this is the sparse volume. So it's more getting closer to particles, where it's just, you could look at this as the active voxels as points. This is much closer to particles or something like that. Let me see if this works. Okay. So when you run this wrangle, it's running over each voxel. And you can see this is the visualization of all the active voxels, or the internal Houdini volumes. It always has to be in a box or a rectangular shape. VDB volumes are sparse volumes, and both of these are doing, you just have to do it using different tools, but they're both creating a point in each active voxel. So you can see all the wasted space. Here it was just doing it by the count as 5 million voxels, and here, so it's less information, and that was basically the idea. With particles, what I was doing, my approach was to just do something kind of like a scatter on the geometry, or inside of the geometry in some cases, but you're getting closer to reducing the data that you're needing to do. So that's, sorry why I got sidetracked, but that's the idea, is like doing the gas field from particles. You're just taking a smaller data set and transferring it to the GPU. So with NanoVDB, instead of taking an entire volume, a fat, dense grid, you're getting closer to particles, or your sparse data is less information to transfer to the simulation with the minimal OpenCL solve. Sorry to go on a tangent, get super technical at the start. Again, right now I'm just doing the sparse solving that doesn't use OpenCL, and the reason is it just isn't supported with OpenCL. So if you want to visualize the sparseness, you can do that with object merge. And then if you just go into the pyro solver, and then inside of the DOP network, I think that they have a active volume. And I might need to take a look. Let's take a peek at the spreadsheet. Yes, I think that they have this active. I think I see what happened. So this active might be set to invisible or something like that. Just try this slice. Might just be because there hasn't been any sourcing. The sourcing didn't start until the 5th frame. Okay. So now if we look at this active volume, this is only created with the sparse solver. But it's looking at the active region of your simulation. So this is the advantage of doing the sparse solver. It all gets very confusing because of just it's a weird state that we're in right now, but this is sparse solving that only works with the CPU. If you wanted to do GPU, it basically will require you to work in a rectangular or a box region. So again, it's different than volume VDB discussions, just because of their side effects as implementation. So this is a sparse versus OpenCL comparison or differentiation. All right, we're gonna get back to the visuals, less discussions for a little bit. So what I've been doing was reducing the divergence, which is essentially the expansion, just like to 0.1. Could even try going to 0.01. And then this is basically reducing the expansion capability and just going to more of the velocity spikiness or the force of things. Could maybe just do less velocity. If your velocity is too fast or contributing too much, you'll see it creates the pressure fronts that in turn kind of gives you the bubbles or the same kind of look as the expansion. So if you're just looking for more of a silhouette or more of a shape like that, you might want to reduce velocity to keep it from like pushing itself past the source and creating like big blobs. All right, let me look at my components. So instead of disabling density right now, I'm just reducing the value to be pretty low. The reason I'm doing that is because when the sparse solver is sourcing stuff, you can see without a density field it crops the existing information. So it's set up to use the density field to track kind of what voxels to activate or what regions to activate. So that's why I'm just doing a lower value instead of completely turning it off. I might leave some of it. I think visually it kind of looks a little bit interesting. I just didn't want it to be complete black smoke, because if you're like exploding something, it doesn't make sense to have black spikes of smoke and then like a hot core, I think. It just doesn't, it's like weird that the temperature wouldn't travel into those areas as well and make it bright. All right, let's merge them both together now. So again, this is where it was with just the one source, the bubbly expanding force. So I'm trying to get more definition, more spikes, more of a silhouette before the expansion happens. This is just a matter of taste. I think like not one is better than the others. It depends on the explosion of like, you have more shrapnel, you have more individual like directional things, projectiles, versus like this might just be a big oil tanker or something like that, where it's just like one fuel source that's mainly just going upwards. So it's can be cool to get more isolated individual features and stuff this way, I think. And then in this scene, I don't know where he went. I did make this little man. It's kind of cropped halfway out of the camera or whatever right now. But that was just my kind of like reminder of a scale, sense of scale or whatever, to get a, for timing and motion purposes, you just want to make sure that this is moving how fast you would expect it to move for something of this size. So like if this is a little firecracker, you'd expect like instantaneous, like 1 or 2 frame, over 1 or 2 frames, the whole like event would occur. But for a really big explosion, it's like 2 minutes or something like that. 1 or 2 minutes. Then the super big ones like that tower in Beirut is like 10 minutes or something. It was like, took time to travel. You could see it traveling throughout the entire city blocks and stuff like that. So look at frame 63. I also have render the previous one. This is a good way to compare somewhat like frame by frame. So you look at frame 64, you could see visually it's just a different, is more of a mushroom or round shape. And then this one is broken up kind of more nicely, I think. Super detailed. Yeah, this was the render from what I had been. So this is the flipbook, and then render you can get a little bit more detail. This is just a mantra render. You have a little bit more control just over color and stuff like that. Let's just go back to the source. Just the spikes. So I have these named differently, spikes, and this is kind of our main like core expansion. I might make the size of this even bigger. You can try different random seeds if you want. And then these other components have different seeds that you can try as well. So I was just going above the previous value to try to even more accentuate or force bigger spikes. I think, let me see if this works. Could try like reducing maybe the number of trailings. I think having too many of them and they'll all kind of like overlap and blur together. But if you really want the spikes to kind of stand out, if you just have less of them, it becomes more like visually apparent. And then I think this one is offsetting the start frame. Let me see if I can bypass that step. Maybe it's, I don't know where that start frame is. I think up here. It's getting set. So I could move it over. And I think this one was randomizing the start frame slightly. So maybe I want this. Go to 3. Maybe 4. So I'm just trying to get these spikes to happen 1 or 2 frames earlier. It's maybe a subtle difference, but this is another thing that I think is more realistic to explosions, where you have like the leading edge, the leading spikes, and then the bigger expansion. It's just like a 1 or 2 frame difference, but the opening, like the first 10 frames of explosions are pretty important in like not only driving the rest of the look, but just your first like visual read of the event. I'm just gonna go with a slightly lower voxel size. Gonna set this, turn off the 3D texture, the volume resolution limit. Go to a new directory. It's the 28th. This is no longer GPU, it's Sparse. Just call it, go back to version 1. All right, we'll do another synchronize of the file if you guys want to get up to date the changes that I was doing earlier. We'll do a flipbook. I'm gonna turn on this character before I do that. 53 minutes in for a first save. I have some other things that run that save incremental files, so that's generally why I'm less concerned about doing the incremental saves. So because these trails are happening and then that bigger blast is coming in, when this comes in and expands, it will shoot things up into the kind of existing motion instead of, without that, everything is just universally kind of expanded outwards. So that's, to me, one of the big advantages of like working with particle sources, compositing them together. Why does the lower part slow down after the initial burst? Right here, I think. So I think it has to do with pressure. It's like you have negative pressure, you have positive pressure, you have negative pressure. You're trying to put a lot of velocity up in one direction. The pyro solver, or every like fluid solver in Houdini does the project non-divergent, which tries to basically preserve the volume, or like you have air flowing. If you have two things going at each other, it's going to force them apart. So there's a similar idea here of like all of this momentum, or there's velocities going straight up, so it has to take things in front of it, push it aside or around, push it back in the other direction. So it's like things going like that, if that makes sense. It's kind of because of the pressure up top, yeah. Could do a visualization of the pressure after, a little bit after this, if you want to look. Yeah, so it's depends on, like, if you were in outer space, maybe you wouldn't expect, there's no pressure or there's no air to do that. Sometimes people will still add it in. Jeta blowing up. I don't know if what is this, Jeta? I don't know what this is. What have you guys gotten me into here? The planet. Jetta. Jeta. Yeah, it's a bit like that, I think, adding the spikes in. They're kind of breaking rules and stuff like that, because like this outer space, like once you get into the full vacuum of space, like everything would be spherical or whatever, but with Star Wars they still do spiky explosions or whatever, because you expect to see them. But yeah, definitely this one I think is a really cool one. So it just depends like on your taste or your art direction or whatever for the shot. Like this you'd see is a little bit more bubbly. It still has some of these trails that these other fire trails things will make. Ooh, we got some disruptors in here. You guys teamed up? Colluded? All right, so we're frame 62 or something close to that. You kind of see the differences now with the spherical shape. These initial spikes just help define overall more of like the end direction, because that will just kind of expand from there. But maybe one day, that would be a good thing, I guess, if I need mods and not a bad thing. So some of the other shaping is happening in here. There's dissipation that vanishes the smoke over time. It just like decreases it. It just multiplies it down or fades it out over time. Disturbance. This is like the blockiness or the chunkiness of it. Generally, you want it to be really high frequency to create this like pyroclastic little bubbles. And then the turbulence is the bigger, large scale kind of like swirling motion of things. Might want this turbulence. I'm gonna try making it maybe a little bit bigger. Yeah, and then if you want, we can do a quick, after reaching 10K, I don't know if that's gonna happen with the Houdini stream. So we'll take the, instead of getting the active field, we can just pull in the pressure. So we'll visualize pressure. And then this field, usually if you do is volume slice, it's a better way to inspect like the values. So it does have negative, like I was saying, is negative pressure that will push stuff back in. So if you want to visualize like negative voxel values, doing these slices is a good way to do that. Houdini becomes cool, the kids. All right. So I think I'm set up here. I can do another flipbook. We'll see what happens. So I think my ranges, my pressure range is a bit off. It was like too narrow of a range that I was looking at. HIP files are the new main currency. The new loot crates is a HIP file. So this purple color is the lowest pressure. It's like means that the value is lower than negative 0.75. And then anything that's completely red means that the pressure is above 0.75. So you kind of see how that is contributing or how that's happening. Does that kind of make sense to people? But yeah, that just means like the result of the pressure field is just the result of the like non-divergent, or what's called the pressure solve. So that's just kind of injecting velocities to make try to make the flow of things non-divergent or not expanding. Obviously, we're modifying the divergence field. So we're messing with the expansion ourselves, which you sometimes have to do with explosions. But visualizing this pressure field, it can be kind of see it a little bit, just kick in at certain moments. But that's what can kill the volume, is we're forcing more stuff up. It has to pull in, or suck in volume from kind of suck in motion from underneath. All right. So I'm just going to go to even lower voxel size and get closer to like something to render and see what it looks like. Another thing you can see here is like the bigger blocks in this pressure field is because we're doing the sparse solver. So you can get some weird like grid artifacts because of the sparse solver, but generally just like the benefits or the optimizations, like the time reduction of keeping the other voxels inactive, is you'd rather have that than some like stair-stepping artifacts. Again, as the sparse is like it, because this pressure field is something visually we don't care about, it's not too important that we're like visually really seeing the sparse region or whatever at the edges of it, or the border. All right, I'm gonna leave this flipbooking. It's sort of 1 minute in or something. I'm gonna leave it going for a little bit. I'm gonna get some water. So it's just starting to get kind of the final level of detail. We're going to this lower, smaller voxel size or a higher resolution. So because we're doing the particle sources, our shape and everything is like still mostly the same, but just starting to add the little bits of like extra nice details and stuff like that. So we'll do what was this? What was that? We were at 0.01 before. We were at 0.1. Let me check. Yeah, we were at 0.1, so I'm gonna go down to 0.085. Maybe 0.08. So as you get closer and closer to like final resolution, you just want to take smaller and smaller steps in reduction. This is like voxels, or a volume is 3 dimensions. So each time you like make a increase in resolution, the size, the overall like memory footprint and stuff goes up at like a cubic. It's like a beyond exponential rate. Then I'll just be caching this one to disk. We'll save the file again. Gonna do save in background. And if you want to get the scene, we'll do another distribution of it. We'll take this cache once it starts simulating and start going into some rendering stuff. So I'm using Mantra to render these, mainly because Redshift isn't like the main beta. I mean, Redshift 3.0 is like already like beta territory or whatever. The builds don't have, they haven't built it for 18.5 yet. So I'm just gonna stick with Mantra for right now. No Genome, how's it going? Wait for a rework of the RS volume. Yeah, there is a plugin that the developers and stuff have pulled in, but generally I don't get too much into the weeds with that stuff. It just becomes too much busy work with the already like working on other stuff for clients, working on, it's just be too much stuff like in flux or in a state of change. If you want to render with Redshift, you can. Usually I'll just write out the volume and as a BGO and open it with the older version of Houdini. And that's a better way to kind of, it's just how I prefer to keep things like separated or whatever. But you have to be a little careful, like staying on the bleeding edge of plugins and all that stuff, especially if you have clients that are depending on like work being consistent and things not, you yourself not breaking things and crashing things and stuff like that. But yeah, the RS improvements are pretty exciting with the volume. Hopefully the volume shader gets better. I'm really looking forward to once they finish the what is it? OSL shader. It's an open shading language. You should be able to do kind of similar stuff as like Vex or just more advanced like shader effects and stuff like that. So I'm looking now after this pyro look node. And again, this one does something pretty important with the scatter. It's simulating or faking indirect like scattering of the emissive area. So without the scatter, you can see visually like kind of looks a little cartoony, or you're just seeing the emission and then right in areas of dark smoke next to it, it doesn't look as realistic. So generally this really intense light scatters or bleeds into the dense smoke. So that's what this scattering volume is meant to do. It's kind of nice that it's like artist friendly. It's like instead of simulating it, it's just doing it using the VDB smooths or VDB blurs. So you just have a little bit quicker feedback on like the final look and what you're getting into. So you do less blur iterations and that will reduce the radius of the blur. You can also just reduce the radius itself if you want like a crunchier or narrower blur. And then I think at a certain point you want to be a little bit careful. This is giving you this warning here saying some viewport visualization features might not be visible. This does not affect rendering. I think what happens is that this viewport, they're unable to visualize both the scatter and fire at the same time. So they're basically saying what you're seeing in the viewport might not match like your render when that warning flag comes up. So when I turn back on the scatter field, you'll see that warning flag come back up. So I think it's just the way that their viewport shader is set up is they're just unable to have more than one like emissive volumes being displayed at once. So you can see that scatter and temperature, like they have more than one volumes that should be making things bright. So this is just a warning to be careful about. And then if you want the real result or to see what the render looks like, go into the mantra and do a render of it. So you can start to see here that we're seeing more brightness because we're actually seeing some of the fire field that's hidden that the viewport can't display right now. So that's one thing to be careful about with the pyro visualization, or when you're using this pyro look. I'm gonna do a new, let me see how many frames I've simulated, 38. I'm gonna do a new mantra node just to show you guys how I got to these settings. Just to talk about some of the rendering settings. There's a little bit of tweaks with mantra that are useful to know about for rendering volumes. So I might go into override camera resolution, maybe just do a quarter res, maybe half res. So just gonna do a render with the default mantra settings and see how long it takes. So we're maybe $35 seconds, roughly like half a minute. 37 seconds. Just make a snapshot of it. Then we'll start to go into these settings. So I'll usually turn off ray variance anti-aliasing. What that is doing is basically trying to shoot extra rays to fix noise or reduce noise caused by like shadows or lighting or stuff like that. So with volumes, we don't really have too much like shadowing or things like that. We just have a little bit of lighting information, and the volume itself is like the smoke itself is so dark that you don't really notice too much of like that additional noise. Looks like there is some breakup here, but generally it's not a big difference that we need to worry about. So just that one, disabling that one setting. This frame here was taking like 37 seconds, and then this one was just taking 18 seconds. So that shaved off some time. Another thing you can do is maybe reduce the pixel samples. You could go down to 2x2 instead of 3x3 if you want. And then we're down to something like 5 seconds. So again, it's just something where it's like a volumetric element. I think it's already kind of like pretty blurry and soft. It's like you don't really need to do a ton of anti-alias settings like this. If you're rendering things with textures or hard edges and stuff like that, you might want to do more pixel samples. But for explosions, you can kind of get away with less pixel samples, I've found. So it looked like this render took a little bit longer because I was doing like a full, if you click the render button, it will like reload the volume, restart mantra, and it will take some extra time. if you're just tweaking settings, it kind of already starts with the volume in memory, so you'll get a little bit faster of a result that way. The step rate, this is something you might want to go higher with, especially to fix this little bit of noise, and you'll see more of the detail of like the masking and stuff like that. So what this volume rate is doing, if you say the volume step rate of 1, as the renderer is marching, or the rays are stepping through the volume to compute the final result, setting it to 1 is saying to visit every single voxel, not skip any of them. If you set it to 0.5, this is saying to basically visit every other voxel, or you're stepping through the volume at twice the rate. I think I can do the documentation that Side Effects provides is actually a better visualization of this than I can describe. I think it's on this. This isn't the one I'm thinking of, but it's on this page, I'm pretty sure. So it's been renamed to step rate instead of quality, but I believe the numbers here are the same. So you can see when this is 0.5, it's saying visit every other voxel, or step through, skip, sample this, skip. So you get a quicker result because you're not visiting as much of the volume voxels, you're not sampling as much information, but you start to skip. Like you might surpass, or you might skip a feature that you want to see in your render. So with this set to 1, we'll just do a snapshot. You see that we catch a lot of the really high frequency or small details. If we go back to 0.25, this is going to be quicker because it will sample a quarter of the volume values. But you can see we blur out or skip the high feature areas, the really fine scale details, the little harsh edges. So generally, even though it will make things slower with explosions, I'll move that setting to the step rate to 1. So if we go back to even the default settings, you can see even that was skipping or wasn't picking up some of the smoke, like the really small details of those hard edges. Like visually, I think it makes a pretty big difference to have that. It really helps make things look. So at 1, it's sampling every voxel. Yeah. It doesn't. They don't show it in this image, but it would basically be this entire line would be lit up. So if we just do the 0.1, that's like 10% of the voxels. Is really low sample rate or step rate, and then completely blurry if we do like 1% of every voxel. If you go above 1, I think it just is similar to like pixel samples or stuff like that. It will just be sampling the voxel, the same voxel, just at more than one position. So it's kind of like an anti-aliasing effect. It might reduce some of this noise if we go to 2. Not a ton. Generally, if you want to reduce this little crackling or whatever, I would say to increase the stochastic samples. And just bring them up higher. If you really want to get rid of them, you can start to do more pixel samples with the ones up here. But eventually it will get to a point where it's like, I don't know, generally like diminishing returns, I think. Could go up to maybe 9 by 9. It's gonna get really slow. It's just not a big payoff for this speed reduction. But if you really want to get rid of that stuff, if you're doing like just a single image for a poster or something like that, maybe you really want to clean up some of this noise. In motion, I think it doesn't really matter that much. It kind of like adds to a little bit of the detail, some of the crunchiness or whatever. But if you really want to get rid of it, I would say to increase stochastic and increase overall pixel samples. So right now it's basically the volume voxel size is smaller than our pixel size. So that's what causes these high frequency flickering. So that's why you have to do more than one sample per pixel when you have like really high resolution, high frequency volumes. Does that make sense? Stochastic is basically transparency. Yeah, I don't know the best way to explain it. I've never had, I've never found a really good one. It's kind of doing these like, I don't think this picture does the best way of illustrating it, but it's basically like shuffling the values to sample them along random positions of the ray instead of, if you turn it off, it will get really slow, but then that will basically be like no randomness. I don't know, there's been papers and stuff written about it. It's a really technical rendering terminology. You could look at the SIGGRAPH papers and stuff like that, but generally I'll leave it on and just increase it to reduce the noise. Like if I turn it off here, you can see it's just super slow. It might take like an hour or something to render this image. So just turn it on, maybe go back to 2x2 voxels. If we go back to this visualization or the SOP network here, what I was saying about with pixel samples and stuff like that was just do the VDB visualize tree. So basically, my voxel size of this, or the resolution of this volume, these are just the leaf nodes. They aren't even the actual voxels. Leaf nodes, this means that it like encapsulates like a 16 by 16 volume block of voxels, I think. If we just go down to the active voxels, it's going to be pretty slow. But basically each point here is an individual voxel. So even the render pixels contain more than one voxel. So that's why you might need more than one pixel sample to try to sort out like spatially how many the differentiation in voxels. So even get pretty close before these things are becoming like the size of a pixel. I also reduced the resolution of the volume so that creates like a little bit of aliasing. Like if I did the full resolution, then we would fix a little bit of this noise because we would be rendering more pixels. So these are pretty much the only settings I'll change with Mantra. Rendering volumes, just turn off the variance anti-aliasing to get a little bit of a speed increase. Reduce the pixel samples to 2x2 if you can. For explosions, a step rate of 1. If you're doing clouds or stuff like that where the values over the volume don't change too much. Like if we weren't doing fire and smoke, I could get away with a volume step rate of like 0.2 or something like that. But because we have these abrupt changes in such a small change of space, you need to do a higher step rate so you don't miss the fluctuation of values. Like if you're just doing a cloud or you're just doing smoke, you can do this a lot lower because the changes of like brightness of voxel values don't differ that much over space, so you can sample it at a much lower rate. So you can see even the higher resolution, there's still a little bit of pixel aliasing, but again, it's something up to you. Sometimes this crunchiness can be advantageous of like just represents really high frequency temperature changes. All right. Let's see where the simulation is at. 66. So it should be good enough for now. Just gonna kill it. So the simulation with the Sparse solver is using the CPU. Mantra is also using the CPU, and all of these shading tweaks and stuff use the CPU. So just to speed up this stuff, just disable the simulation. 66 frames should be more than enough for just looking into this right now. Alkama, thank you for passing by. I am doing all right. I'm hanging in there. So again, with this visualization, we're just probably going to want to do a quick render. Again, with this warning, is saying viewport visualization might not match the render. So let's take a look. How you doing, Alkama? I was looking at some of the shaders, some of your shader toy stuff over the weekend, trying to learn. So I was doing a lot of Vex programming stuff in here recently, been getting a little bit back into shader toy, that stuff. They reconfine. You're in the EU somewhere. Seems like in France. Yeah, I saw France, even Spain and Portugal and all that, their stuff was spiking. Spend the night coding. Yeah, I mean, it's really good to have hobbies and work on these skills or whatever I found during this time of confinement. So here you can kind of see the differences of this spread. The scatter volume wasn't fully getting honestly represented by the viewport. So just doing a render to get like an exact representation of your settings can be nice. When is this next revision? Easter. It's just once a year? They did it completely remote this year? So yeah, I think the scattering is maybe even better than it was before. I'll just go back to my previous render. I think it was a little bit too big of a scatter range here. It's up to you, but oops. I think it's a bit nicer when it's just a subtle expansion into the smoke. But it's up to you. And then the step rate at 1 definitely helps you capture this kind of like crackly detail. If I do another snapshot and just do this. I'm just going to reduce the volume step rate so you guys can see the difference it makes. Let's just go back to the default setting, 0.25. So you see the speed up is pretty big, but the overall resolution, it just looks like a lower resolution volume, or it's just less detail. So certain areas you might think maybe it looks better, but I don't know, this stuff here is pretty questionable. It's just pretty bad artifacts of like skipping too many voxels. You won Meteorix? Doomed? What is Meteorix? You're doomed, but you're gonna emerge from the confinement of 4-time award winner. So yeah, I think it's better to keep the step rate at 1. If there's things about this you like, you could just try to boost it in the settings, like boosting the intensity or the scatter or stuff like that. Because it's not a good idea to kind of rely on those artifacts or whatever. So yeah, that's that. I'm just gonna make this. Sometimes I'll make my render window full screen when I get close enough into the final tweaks. That will just make jumping around the network a little quicker. You won't have to. Sometimes when you jump in and out of networks, like it reloads the volume for lighting changes and stuff like that. No redshift. Yeah, I'm not doing it right now. Maybe I'll get to it eventually. So you can, like I was saying earlier, you can bake the emission volume. And then I would just write that out as a BGO to disk. And you should be able to get something that matches this pretty closely with Redshift. With the one thing I will say about Mantra is that it is rendering volumes or explosions with it is definitely where it works the best. It's like it gives you really quick results, especially when you're baking the scattering volume like this. And this is definitely like the fastest. The best that Mantra is when compared to other renders. Like if you try to do an architectural like interior scene, Mantra really underperforms in that area, but volumes, it's like what it was almost built for, what the developers have spent a lot of time improving and stuff like that. So if we look at this, when you double click on the pyro look node, this does bring you right into the material for it. You could make some adjustments. Usually I reduce the scattering phase of like clouds and stuff like that. You want them to be a little bit more forward scattering, but for really thick like oily smoke, sometimes you want that to be backward scattering, or like less able to kind of conduct the light, I think. And then under exports, you can see here these image plane exports. These are all AOVs, but these are all variables that you can store as AOVs. So if you want to point this node to your Mantra, your render node, they have a nice little macro here that you can click. It says update nodes with image planes. If I go to my out network, what that does is it just runs a little script that goes into my extra image planes here and automatically adds the extra planes for me. So we go, you can see up here now, we have one just for the smoke. It's so dark, you don't really see it. I might need to click it again to reboot. Maybe the renderer didn't detect these changes yet. Okay, so now we get these nice AOVs if you're doing compositing. If you're making sprites for a game engine or stuff like that, it can be nice to have access to these. Do like color masking or color correction. Instead of doing this drop-down menu, you can also do the shortcut. If you do Shift and then the left and right square brackets, that advances you to the next or previous image plane. So if you're just flicking through all of them quickly, doing Shift and left and right square bracket, it's a quick way to do that. So you can quickly see, can isolate the scatter volume. If you want to do color correction, just maybe to oversaturate this or multiply it up or down, it's just additional control that can be nice in the compositor or after post-render, essentially. Bloom. Bloom to the scatter and boom. Yeah, that is something that's definitely missing. So with Redshift is nice because you can do post effects and you can do some of those things at render time and get the result. Here you can see is, just because this is all mantra renders, it's kind of missing like a lens flare or at least a little bloom on the explosion to make things the in-camera kind of photographic effects to really put things together. But yeah, I think this is a little bit nicer of a shape overall. Just a little bit more broken up of like a silhouette for the explosion. Especially compared to the last one that, I mean, kind of depends on your art direction, like I've been saying, but personally I like a little bit more breakup, initial spikes and stuff rather than just like a big blobby kind of sphere. It's just a little bit more boring or uniform or whatever to look at. It's almost like the... You guys ever seen this Photoshop thing where it's like a clown-shaped mushroom cloud? I don't know where it came from. It's like a famous thing, right? It kind of looks, some of it looks like this a little bit, right? I guess the tip of it isn't as much of like a stem. This is like more of a nuclear. I think because this has a lot of initial upward direction, it gets this like long, skinny stem. This is a little bit worse, I think. Could be. I think it's a little bit nicer to have like a silhouette like that. But yeah, it's definitely nice to know how to control that kind of stuff. Just gonna go back to the first frame here and then back to the viewport. If you guys want to get the, let me go back here. All right. If you guys want to get the updated scene file, do another distribution of it. And then I'm gonna just wrap things up here, doing another flipbook. So you can just check out the simulation results in a quick preview. So it's not gonna match the final render look or whatever, but for judging the motion and timing and stuff like that, it could still be nice to do a flipbook. It's faster than trying to bash out a render at the last minute, at least. So these settings up here that are more orange or whatever, these are just from the Sparse solver, or the up here it's kind of hidden. The simulation node itself has a different visualization settings. So yeah, I generally think it's pretty cool to have like the initial bigger spikes and then have those get expanded outwards instead of just starting with like a single sphere and expanding that out. I haven't been turning it on because it's like it kind of gets merged in at the end, but having the bigger trails with the fire tips can help build out like compositions and stuff nicely as well. I think the Jetta, yeah, so some of these explosions, you can see they have it. Sometimes they don't do it. Like this is just more spiky, but it's nice to be able to know like how to get those and build them in real quick. So these are the more, I don't know, like Michael Bay uses them a lot, just like projectile flying shrapnel that is dragging some smoke with it or something like that. You could generally add these as a secondary step or a post process. You can see like the base explosion, the look of it doesn't change that much compared to they're not carrying velocities with them, they're not dragging like the main explosion shape with them. So you can do them as separate simulations or an extra kind of secondary effect if you want. I think another thing that's cool to add is the kind of like radial ground level shockwave. Just a ring of smoke that kind of pushes everything outwards. So, something you don't want to use like all these in every situation because you just start creating boring. Everything's going to look the same, but knowing how to do each of these things and bringing them in when you can is a good way to do it. This is a bit of that radial stuff I was talking about, just like a shockwave of dust or whatever. And then I think one of the things, so all of the motion and shaping stuff that I've been talking about has been mostly in the source. The one thing that is you kind of have to adjust in the simulation that contributes a lot to the look is the thermal buoyancy, like how quickly the heat rises, and then the cooling rate, or how quickly the heat cools. So with those two sliders, you can control how much your like initial step is going to travel up, like how quickly it will move up, and then also how quickly that will decay or slow down. So I didn't do it here, but one thing that could be nice to do is like a more quick upward lift of the smoke from the temperature, and then having that deaccelerate very quickly with cooling. But yeah, I'm really liking some of this. Obviously the viewport isn't getting us the honest result, but could see it earlier in here was the really like high frequency crackling, and then combining that with the scattering to get like these broad things that it's really soft detail as well. So I'm just gonna let this get to frame 37, because that was the last one. That was the frame that I was rendering, I think. Or no, that was 64. Could be a long, the flipbook starts to take a really long time with higher resolution volumes. Just to transfer that to the viewport is pretty slow with Houdini. So I'll just take this, stop it where it is, frame 40, 39. Then I'll go into here, go to frame 39. We can do one last side-by-side comparison. So yeah, I really like this area in here. It's feeling pretty natural. Some of this stuff, you might want to do like some tone mapping or desaturation. I don't know, there's always something about this like yellowish color that just doesn't look super natural. So yeah, I think this area here looks really cool. Let's go. So yeah, there it is. The explosion just keeps getting bigger. It's like every tweak. I was adding a lot of like upward trajectory to this one. So we look at this from last week's frame 38. Is just fill the frame here. These aren't going to line up perfectly, but you kind of see the difference of the two or whatever. Just getting more silhouette, more of that detail. Yeah, and then the other big change was just reducing the scatter radius to get a little bit more contrast with less like overall blurriness of things. Yeah, so that's it. Probably gonna leave it here for today. Just a continuation rendering, some more shaping or control with the compositing or layering your sources to work more like a artist, or just have a little bit more control over things. This is the latest file if you want to grab it. I'll catch everyone on Friday for the cool zone. Yeah, of course. Thanks everyone for hanging out and chilling, vibing during the stream. Let's see if anyone, it doesn't look like any other 3D artists are online right now. So yeah, we'll just end it here. We'll be back Friday.